All right, well then I'm going to get started. Hi, everybody. Welcome to the Western Drought Update. I'm Kyle Bocinsky. I am the Director of Climate Extension at the Montana Climate Office, and I'm really glad and excited to be back here with you today, talking about drought as we head into the planting season, into our late spring, or into our early spring, I should say. Lots to talk about today. I'm sorry I'm not there with you in person. It's my kids' spring break and we're on a family vacation. But what I want you to know is that we've got Maureen and Vicky here listening in today. They're going to ask some questions to me, recorded questions at the end of this. And then if you have any further questions, my email will be at the end of this presentation. Please don't hesitate to reach out. I'd be happy to chat with you about conditions in your local area. All right, let's get started. So here's the summary. Here's what I'm seeing on the ground across the Western US. The first thing to note is that drought conditions do continue to dominate the Central Plains and portions of the Western US. We're not out of the woods when it comes to drought by any means. We'll get into that a bit later. The big news, an extremely strong series of atmospheric rivers has flowed across California, the Great Basin, and the Southern Rockies. And that's caused historic snowpack, which is good, but also flooding and landslides. And whether we actually reap the benefits of all that snowpack is still an open question. So we'll get into that some. Drought is expected to continue or worsen across the southern and central plains, as well as portions of the Pacific Northwest. And what we're not seeing is the snow helping the central plains at all. So keep that in mind. Historically low reservoir storage persists in the Colorado River Basin, and it continues to be of extreme concern. We've got good snowpack in the high country. Hopefully that will help a little bit, but we've got historic consumption as well. And so those low reservoir levels are gonna remain a concern. And El Nino conditions are expected to emerge by midsummer. We've been in a La Nina cycle. We're coming out of it, and I'll get into that. And we're expecting El Nino to emerge by midsummer and will likely persist and influence the conditions during next winter. All right, so here we are. This is the current US drought monitor across the US. This is as of yesterday for me, as of last week for y'all. What we have is really exceptional drought conditions in Kansas and portions of Oklahoma and the Texas Panhandle. And in fact, the whole Southern Plains continue to be exceptionally dry, where we have not gotten the snowpack this winter that we would need. In fact, we haven't gotten it in the high country either. So unfortunately, I can't say that any relief is on the way. This has just both immediate impacts in terms of this growing season, but also are having long-term ecological impacts on this region. Just really dry conditions that's reflected in soil moisture primarily. What we have seen is an amelioration of drought conditions here across California and up across the Great Basin and through the central Rockies. We can see that in our animation here. I always like to show this because it really does show the genesis of drought since the beginning of the drought monitor in the year 2000. I'm gonna move way forward in time to where we are now. Ooh, here we go. We're flying. To get us close to this latest drought cycle when we started right about when COVID hit. Honestly, we started seeing a really large drought cycle affect the entire West. Here we are in late 2020, winter of 2020, extreme conditions, exceptional conditions across the southwestern US. It moved over into the Sierra Nevadas in the Cascade Range, and continued to be really bad and persistent until very recently. And that's been our big story. We had these series of atmospheric rivers starting in late December, really ramping up in January and persisting through today across the Sierra Nevada. And the question was this going to bring some drought relief? Many of you probably remember in the news a lot of warnings during those first couple of AR events where hydroclimatologists were saying, don't count your eggs before they hatch. This may not solve the drought. I'm here to say that it probably is still not solving the drought, but we have seen exceptional soil moisture recharge across California, and it's starting to really work its way across portions of the Great Basin as well. What I want to do is show you, we've been doing this lately in our native climate drought updates, where I show you the trends for each of the basins. And the graph that I'm going to show you, it's going to be a series of graphs, and it's going to go from north to south. So Pacific Northwest will be first, and then Missouri, then it's got to come across California, Great Basin, and the upper Colorado, and then come across the lower basins. And we see this big drought that started in 2020, and the way that it moved sort of south to north across from Texas all the way up to the Missouri River Basin. And then we had a second pulse of it starting in Texas and moving its way up. However, what we've seen in the last few months since midwinter is for California and the Great Basin, that amelioration of drought conditions. We're seeing drought persist at pretty even levels up here in the Pacific Northwest. A little bit of a decrease in drought conditions across the Missouri River Basin, some nice recharge across the Colorado River Basins. That's really a bright spot right now. And then persistent drought conditions across the Rio Grande and Arkansas River regions, and increasing drought conditions across the Texas Gulf region. We can see that in a longer term perspective going back to the year 2000. Once again, and I highlighted this back in September, and I think it bears repeating, we do often see this pattern of drought emerging first. If you look across all these basins in the West, emerging first in the Texas Gulf and Arkansas River regions, and then moving north through the Rio Grande, the Colorado River Basin, the Great Basin, California, and then finally up into the Missouri and Pacific Northwest. We see that sort of progression of drought often through the last 20 years. And I'm really wondering whether we're going to see it again. We're starting to see conditions tick up in the Southern Plains region in Texas and Arkansas again. And in my expectation, and I'll go into this a little bit more later, is that we're going to see that wave of drought move back up across the country over the next couple of years. So once again, here we are in our latest drought monitor, and this is as of the 16th of March. We've seen, as I said, a dramatic amelioration, a dramatic reduction of drought conditions since the start of the calendar year. 4 and 5 classes of improvement across California, the Central Valley, and then you see this sort of swath of improvement coming up through Nevada and Utah. And of course, that is because of these atmospheric river events that we've had over the last 3 months. I really love this image from NOAA, which shows one of those Pacific lows that we've seen hitting the Pacific just right off the coast of California and Oregon, creating this large, we call it a fetch, this atmospheric river, this incredible amount of moisture that, that when this storm system moves on land, that just cuts straight across California. And that's what we've seen time and time again. These things spin down from the Gulf of Alaska. They pull in tons of moisture from Hawaii effectively, and send it across the Sierra Nevadas and the central, the mid latitudes. Here is the last 90 days. This is as of this morning, the last 90 days of precipitation. So winter 2022-2023 across the United States. And we see that dramatic, over 200%, some cases 300% normal precipitation hitting California. And you see the path, that the normal path of these atmospheric river events. They've been coming straight across the Sierras, across Utah, southern Wyoming, and actually influencing precipitation as well in portions of the upper Midwest. They haven't come across as far north as I am up here in Missoula. I live here. We've been having a drier than normal winter across the Pacific Northwest, which is a pretty unusual way to experience a La Nina year. I'll get into that in a minute. And then this exceptional dryness and lack of precipitation across Texas, eastern New Mexico, Oklahoma, and into Kansas. And that includes the eastern side of the Central Rockies, right? So, so areas around or just east of Alamosa and the headwaters of the Arkansas River have not been getting the precipitation that areas north into Wyoming and in northwestern Colorado have been receiving. And that doesn't help the situation in Kansas. At the same time, we have had an exceptionally cool winter for those of us in the Western US. We've been hearing about how unusual the warmth has been in the eastern side of the country, with New York having one of its latest snowfalls on record. Most of these states being in the top 3 warmest winters on record. Green up, leafing happening across the Southeast 20-30 days ahead of schedule. So it's having real big phenological impacts across the southern US. But out here in the West, it has been cold, and that has enabled these atmospheric rivers that have come through to dump just incredible amounts of snow. And it's also reflected in this. This is the standardized precipitation and evapotranspiration index. Now, not much evapotranspiration happens in the winter. That's both evaporation off the landscape, off of water, and from plants, that evapotranspiration from plants. Not much of that happening during these cold temperatures. So this is really, once again, a record of that really unprecedented precipitation and water availability that's come across from these atmospheric river events. And it's led to just to this situation, just incredible snowpack numbers. I mean, we're talking upwards of 270, 300% of normal across basins in the central Sierra Nevadas. The upper Colorado River Basin here, lower Colorado, upwards of 200, 180% of normal. Just really, really great snowpack for this time of year. Large amounts of snow. Now we're already starting to see some of the impacts of this large amount of snow when we get melt events. California's been seeing that directly with each one of these atmospheric rivers where we get really large snowpack. And then if you have a slightly warmer system come through, dumps a lot of rain, warm rain on top of that snow, can accelerate snowpack and have deleterious effects like collapsing roofs. What we're seeing down in southern Colorado right now is some early season snow melt and flooding in the Cortez area and Dove Creek as we speak right now. So we've had this historic snowpack in California, the Great Basin in the lower Colorado, high snowpack in the upper Colorado, 140%, 129, 148. Those are good numbers. 158 here in the San Juan, that's draining down into the Navajo Nation. Normal snowpack across the Columbia and Missouri headwaters. Notice here, we're right about, these greens are just right about at normal, right at 100%. But what we have here is actually one of our more concerning things. This is the headwaters of the Arkansas River. And what this says is that it's at 81% of normal. So you might think, oh, it's just 20% less than normal. That's not that bad. But when I actually show the stations on here, these are each of the SNOTEL stations. Vicki, I see your hand raised. I'll get your question here in a second. These are each of the SNOTEL stations. The way that these numbers are calculated by the NRCS is that they take the SNOTEL stations, the snow measuring stations that are inside their basin, but also some that are just outside. And what we're seeing is that those that are just outside are pretty high, but those that are actually in the basin are really low, less than 50% normal. So what I'm seeing is that we really are having almost a rain shadow effect with these storms that have come across, where they're not getting water into those eastern draining basins. And that's a problem for especially the Arkansas River and portions of Kansas and Oklahoma that are downstream. And we're seeing a real water availability problem in those already drought-stricken areas. Vicki, did you have a question?
I just was wondering if you'd explain in producer terms what atmospheric river is. I think we're gonna have a lot of people that are unfamiliar with that term.
Yeah, that's a good question. And really the best way to look at it is this picture right here. An atmospheric river is just a large amount of moisture that's streaming in overhead. It actually can be 5 to 15 times the amount of water that normally flows down the Mississippi River. So it's a huge amount of water streaming in overhead, caused by these Pacific lows as they're just sucking moisture off of the Pacific Ocean, warm, moist air. And when they start streaming over the mountain ranges, either the coastal ranges in California or the Sierra Nevadas here, they get lifted up, and that causes them to release a lot of that moisture as precipitation. So what they are is literally just storm systems, but they're not big, wide storm systems like you might think of that we get on the continent here. They're narrow bands of moisture that come flowing in off of the Pacific Ocean and drop a oftentimes extreme amount of water. And these atmospheric rivers that we've been having this winter, where we've had 9, I think we're actually on our 10th atmospheric river hitting the California coast this winter so far. These have been pretty exceptional events in terms of the amount of moisture that they're carrying and the amount of snow that they've produced on that landscape. Once again, because it's also been a cold winter, we're seeing much of that water falling as snow at this, or at least over the last 3 months. And that's just caused really unprecedented snowpack in the high country.
And so once these hit, and you showed that pattern that is right there through the middle, that just dissipates. It's not like normal weather and it travels on, right? It just hits and
it hits and you get the biggest impacts, the biggest dump of precipitation when it first goes over the mountains. But we've seen the moisture from these continue inland and then mix with moisture that's coming up from the Gulf of Mexico. So we've seen some pretty long distance impacts, and we can get those impacts inland as well. I mean, as Maureen will remember, and as those of you up in Montana will remember, our big flooding event last June that happened in the Yellowstone area, that was an atmospheric river event that came in over Washington and Oregon and dumped a lot of rain on top of snow that was primed to melt. We had a really cold June, really cold May, and so we had a lot of snowpack, but it had started warming up, and then it dumped rain on top of that snow that accelerated some of our snow melt, and we had those historic floods. So these can go quite a ways inland as they're coming across the West. Maureen, did you?
Yeah, so ARs are typically thousands of miles long. So that imagine it being a conveyor belt pulling moisture out of the Pacific Ocean. Sometimes as, at least as far away as Hawaii, often all the way even further in the Pacific. And as the oceans are warming, more and more moisture are going into this giant conveyor belt. They don't always hit California, although the way the patterns have gone this year, that is the parts of California, Northern California and Nevada that are being hit, that's the majority of precipitation that they get. So in a year like this with lots of atmospheric rivers, they get a huge amount of precipitation. When we have very few ARs, it's typically very little precipitation and drought in the Northern California through the Great Basin.
Right. These atmospheric river events are really, and Maureen, correct me if I'm wrong, but they're really an important part of the climatological and ecological systems in these montane regions. They're pretty normal. What's been intense this year is it's been colder. We've had 9 going on 10 of these, and we've just had a lot of snow in the Sierras. And you can see how narrow that band is. So we've been hearing about all this precipitation hitting the West. And if you're not living in this area, you might assume that it's affecting everybody, but we haven't had exceptional precipitation in the Pacific Northwest. We haven't had exceptional precipitation across southern Arizona, and certainly not in New Mexico. So you've got to see, and you can really see illustrated here how narrow of a band this high precipitation region has been.
And so what causes that? Is it pressure? Is it El Nino? What causes
No,
this?
it's I can give an AR talk sometime.
Okay.
But it is not connected to either El Nino or La Nina. And so that's important because even though we were in a La Nina this year, these patterns of storm patterns aren't driven by any of those oscillations. But they are getting more intense with warming temperatures in the atmosphere, because the warming atmosphere can carry more moisture, and warming oceans can put more moisture into the atmosphere. And so we do know with climate change, the projections are that these kind of storm patterns are getting worse. And for the people who are in that region, you will remember 2017 was a particularly bad year. And in certain areas, 2017 still represents more snowpack in the areas. So we've been seeing these patterns where we're getting this intense precipitation series of ARs coming when we're, over time. So I can talk more about that patterns on that. I'd like Kyle to get through the
Yeah, I just want to make sure we explain this really well because producers look at the weather about 50 times a day, and I kid you not, that is not an understatement. So we want to make sure they understand comprehensively what this means.
Yep.
And Maureen,
And I can answer more questions at the end.
Okay, perfect.
Maureen's
Thank you.
point about the lack of correlation between El Nino, La Nina events and these in these atmospheric river events is a really important one. That this isn't this it's not as simple as that. But we do have strong atmospheric river seasons, years, and weak atmospheric river years, and this has been a particularly strong one. And what we're seeing is that there's been a soil moisture response to that. And this is really what the US Drought Monitor is responding to, right? Initially, when we started having these strong atmospheric rivers hitting California in the early part of the winter, the question was, were we going to get soil moisture recharge and reservoir recharge as part of these? Now, what we're seeing, this is a data set called SPORT, which is really what we're finding to be one of the best representations of soil moisture across the nation. We are definitely seeing a strong recharge of soil moisture across California, the Central Valley, and in fact across Nevada. Now, notice up here, these are frozen soils. Anybody who is out on this landscape, Vic, you know that when your soils are frozen and they freeze dry and snow lands on top of them, that doesn't mean that any water is getting down into your soils yet, right? You got to wait until those soils thaw, and it's actually all in the timing of when the soils thaw and when the snow melts, right? And sometimes things can heat up really fast, snow can melt, but if your soils are still pretty frozen, especially at depth, most of that water isn't infiltrating down into the soils. But if you have a nice slow thaw and the water has time, the snow has time to melt down into those soils, you'll get recharged. That hasn't happened yet across much of the upper Midwest, but what we see is pretty high snowpack up here. We'll get into that in a second. And so the question is, are we going to get good soil moisture recharge in these portions of the upper Midwest? Down here in Kansas and Oklahoma and Texas, these soils are plenty thawed. They're just dry. Okay, this is accurate down here in Kansas, Oklahoma Panhandle, Texas Panhandle. Not accurate, not an accurate representation at this point up here in upper Midwest. So I want to look a little bit at reservoirs because that's really what we're talking about here. We've got snow in the high country. We've got our reservoirs, our man-made storage, human-made storage that are in many of these basins. And the question is, are we going to see those reservoirs fill back up to help our irrigated production? So this is the Missouri River. This is basin wide, so all of the reservoirs across the Missouri. These are our average fill levels. This is 2011, the really bad flood year that we had, where we had massive floods, and the Army Corps did major releases that flooded a lot of towns because their reservoirs were almost going to overfill. They were hitting capacity. This is where we are going into this year right now. Really low levels across many of these reservoirs. And the forecast for the remainder of the year isn't for these to go much higher. And the reason is, I mean, we've got high snowpack. This is across the basin. We're at about 200% of median across the basin right now. And now the Missouri River Basin is huge, right? The problem is that most of that excess is at low elevations. This is a different way to look at this water. So I'm going to go through and explain it. On the left axis here, this is representing the entire Missouri River Basin, really big area, right? We have elevation. So what you'll see is that during a normal year, and that's this dark area sort of in the background, Most of our snowpack in the Missouri River Basin at this time of the year is up in the mountains, is between 5,000, 5,500 feet, all the way up to 13,000 feet. Most of our snowpack is usually up in that high country, right? It's up here in Montana. Very little of it is at these low elevations between 500 feet and 5,000 feet. This is the plains down here. But this year, and this is what's in the foreground in this light blue, this year we've got, pretty close to normal up here in the mountains, but we have exceptional snowpack across portions of the northern plains. This is fragile snowpack. And it's on, as we just saw a minute ago, dry soils. So I expect that a lot of this, hopefully a lot of this will infiltrate and restore soil moisture, but much of it is not going to be flowing into our reservoirs the way that our upland snowpack does. So this is why starting off well below normal in terms of our reservoir levels, this is why we're not expected to see a huge recharge of our reservoirs with such high snowpack. It's because most of that snowpack is at low elevations. It's not above those reservoirs. You get my drift? Yeah. Now, our situation in the Colorado River is a little bit different. We are starting way below normal. I don't have one of these nice basin-wide graphs for the Colorado. I've got the teacups for each of the reservoirs. Here's Lake Powell. It's been in the news a lot lately, way below full pool. Lake Mead, almost getting down to a major shortage where it's going to be hard to draw water out of it. Most of our reservoirs, Navajo reservoirs, only at 51%. That actually feeds portions of the Navajo Nation. I don't see one of my favorite ones up here, but these are all real low. So let's look at the snow availability for the upper Missouri or the upper Colorado. Here we are. This is this year. Currently, we're at 234% of normal here in the Colorado River. We're having a really good year in terms of snowpack in the upper Colorado. If we look at that again across elevational gradients, what we see is that a lot of the weight of this is actually in this lower elevation area. So once again, we're going to see some snow melt that isn't going to help as much with our reservoirs. It's helping farmers. It's helping restore soil moisture, sometimes causing flooding, but it's not all accumulated up in the high country where you might want it to be to stick around the longest and then really be able to maximize the benefit to those reservoirs, to those dammed areas. In the lower basin, we're also very, very high above normal, because normally we would expect a lot of melting, especially in the low country, to be happening right now. Remember, this is the lower Colorado, so this is down in Arizona primarily. And once again, we see a lot of that snowpack is at lower elevations for that basin. And so I expect that these are not going to help quite as much with the reservoir levels as we would like for Lake Mead, for example. Here's California. Now, when you're looking at these, you're probably thinking these are full pool would be the orange box. The historic averages are the green lines that we're seeing through here. You're probably looking at these thinking like, wow, they're having such a huge snow year. We've been seeing news about all these floods. Why aren't these fuller? Well, one of the reasons is we're having to release water from these reservoirs because we know how much snowpack is still up in the mountains in this area. We can't keep these totally full, because if we do have one of those rapid snowmelt events in California, we might not be able to release water from them as fast as water's coming in. So they're keeping these at the moment artificially low in expectation that we're going to be having some big snowmelt events having to do with these atmospheric rivers and the incredible snowpack. And that snowpack really is incredible. This is the average snow water equivalent, just the amount of water that's in the snow across the basin. We're at 361% average SWE. That's just an incredible amount of water, and it's still going up. I mean, it'll be interesting to see exactly when this peaks. What's hopeful for California is that, as you can see, this is the normal distribution by elevation for this for California. This is where we are today. The pattern is generally the same. So we're seeing increased snowpack across all elevations. Every single elevation is above 300% of normal, but that's pretty consistent across the elevational gradient for California. This is good. This is what you want if you're looking at it from a water resources perspective in terms of recharging those reservoirs. Now this is just a really unprecedented amount of water. And the concern is that it all melts at once and causes big flooding like we've started to see. But this is good news from filling up those reservoirs. Are there any questions? Briefly, we can pause just about the water availability side of this, going through the snow and in the reservoir.
Yeah, I think this is an important point, which is that for the agricultural producers, that depend on reservoir water, in the California, Nevada area, you're right. By law, they can't be retaining water in those reservoirs now. And so they will be releasing everything they can, and it's going downstream, and it's not available ag water until at least the 1st of April, maybe later, depending on what the melt is. And so they're still concerned that if that melt comes very quickly, the water will go downstream and will not be available later in the season when you need it.
That's right. It is such, it's roulette. They're good at that in Nevada. It is really trying to read the tea leaves about when that melting is going to happen. So let's get into to some of the data that we have to help us think about this. I want to give a brief overview of where we are with the El Nino Southern Oscillation situation, just because we talked about it quite a bit in September, and I want to give you all an update. Once again, this is how we define El Nino. It's all based on the temperatures in the Central Pacific. This is called the Oceanic Nino Index. Pretty much when this line is above 0.5, it's an El Nino. It's defined as an El Nino. When it's below negative 0.5, it's defined as a La Nina. And what we've seen since 2020, we've seen 3 winters where we've been in La Nina conditions. Now, when we met in September, this is the graph that I showed you. This is where we were. And I said, we're going to hit this triple dip, this 3rd winter when we're in La Nina. But the projections back then were that we'd start coming out of La Nina. So I wanted to show you this to remind you what I showed you. And then I want to show you what actually happened this winter. And here it is. We started coming out of it faster than the scientists were projecting. We did come out. I mean, we've come out and we are actually officially in what's called INSO neutral, between negative 0.5 and positive 0.5 right now. We've spent the winter coming out of of the La Nina conditions and entering this ENSO neutral. So we were expecting to do that, but we were expecting to do it a little bit later than actually happened. We just, from pretty much from when we last talked, relative to normal, the Central Pacific has been warming ever since then. And this is where we're expecting to go. These are the latest projections for temperatures in the Central Pacific. The scientists, the models are suggesting that we're going to be going just straight up through ENSO neutral, and then maybe even by midsummer hitting El Nino conditions. Now, El Nino doesn't actually have huge climatological impacts during the summers here in the United States, and it's weaker than La Nina's usually in terms of its normal impacts. But the expectation is that by late summer, we could be entering into El Nino conditions, and then those would persist likely through the fall and winter. And here are those probabilities. They're showing, this is the Climate Prediction Center out of NOAA. They're showing by September, October, November, a 60 or so % chance of being in an El Nino, a 35% chance of being neutral, and we're almost certainly out of La Nina territory by the end of the summer. And here, just to remind you of one of the discussions that we had last year in September, we were looking at the relationship between the slopes of these lines, the period of time where we're emerging out of La Nina and coming up into peak El Nino, and how that corresponds with the persistence of droughts, first in the Texas Gulf and Arkansas areas, and then how that just travels north, so to speak, north and west, up through the Colorado River, Great Basin, California, and into Missouri and Pacific Northwest. As we come out of this La Nina down here, that's what I'm going to be looking at. I'm going to be looking at these conditions in Texas and Arkansas and seeing whether they start trending northward and northwestward and moving up into the Rio Grande, Colorado, and then further north. That is my expectation of what we are going to see, given the persistent genesis of these droughts that we've seen over the last 20 years. Okay, let's get into looking into the future a little bit. These are the 6 to 10 day outlooks. I'm talking to you on St. Patrick's Day on the 17th. You are going to be in the middle of this while I'm talking to you next week, where the outlooks are for below average temperatures across the Western US and above average precipitation. It's going to be another wet week. I'm going camping next week, and I'll be right down here. So it could be a cool, wet camping week for us in the desert Southwest. 8 to 14 day outlook, 1 to 2 weeks, continuing to be below average, especially here across the Sierras. That's big if we get another one of these atmospheric river events over the next 2 weeks, with above average precipitation across the West. Looking at out just into April, so this is the monthly outlook for April. We see below average temperatures here across Idaho and Washington, across the Northern Rockies, but we see equal chances and then warmer than normal temperatures cutting across the southern tier of the US. But crucially, the Climate Prediction Center are predicting a dry up of the southwestern US, California, Nevada, and the Four Corners region, drier than normal across that region for April, going into our early growing season. That's not good for people in the Four Corners. We like it to stay moist as long as possible, because we usually have a dry spell from late May until we start getting monsoons. Looking out April, May, June, this is really your planting forecast. Below some spots of below average temperatures across the West, but pretty normal conditions across the West in terms of temperatures. The Southwest and Southern Plains, much warmer than normal. And this is the really drought-stricken area right now. So that is, these are not the conditions that we really wanted to see, nor is this, where we're seeing below average precipitation for that core planting season across eastern New Mexico, West Texas, and up into the Oklahoma Panhandle. We're also seeing some below average precipitation here in the Pacific Northwest, where we're already seeing drought conditions. So that is going to continue to be a challenge. That translates into the U.S. Drought Monitor's projections for where drought amelioration is going to happen and where drought is likely to persist. And we see drought persisting or getting worse across those southern plains, again, across the Pacific Northwest. And they are predicting that they're going to continue to come out of drought across this central tier where we've seen all of these atmospheric rivers coming through. So just to summarize once more, that our drought conditions are continuing to dominate the Central Plains and portions of the Western US, primarily the Northwest coast. We're seeing extremely strong atmospheric rivers, and these, though at the beginning of the season, there was some uncertainty about whether they would help with the drought situation. They are leading to a reduction of drought intensity across that region. Now the question is just going to be all in the timing. How is that snow melt going to happen? Are we going to have rapid snow melt that leads to flooding and sort of inability to time the retention of water in reservoirs to get us through the dry season? Or is it going to stay cool and keep that snow up in the mountains? That would be the best situation for all of us if that snow would just slowly melt and come down and come to us when we need it across the Great Basin and across the California Central Valley. Drought is expected to continue and I think worsen across the southern and central plains. We're seeing that the snowpack isn't where it needs to be across the Arkansas River basin especially, and that is going to lead to persistent challenges across the southern tier of the plains. We continue to see historically low reservoir storage in the Colorado River basin, and it continues to be a concern. We don't have the snowpack in the upper Colorado River basin, especially at those highest elevations that recharge those reservoirs that we would hope. We're seeing flooding right now. I mean, today down in the Four Corners region in Cortez, for example, where the snow that's on the ground is melting very rapidly and causing flooding and saturation of soils. And then for your INSO forecast, El Nino conditions are expected by midsummer and are likely to persist into winter of 23 and 24. We can talk about the impacts of those at my next update. Thank you so much.
That was incredible.
There's a lot of information.
Oh my gosh,
I mean,
one of your best, honestly, as a producer. That was just all so informative and so necessary. So honestly, you killed it. I don't actually even have a question. So that just that is helping me so much as a producer right now. And maybe not if I'm in the South, but where I live right now, I'm like, okay. So, Maureen, any questions?
A couple comments, Kyle. I think your point about the location of the elevation of the snowpack in the different basins, really incredible, because people are hearing numbers like you're at 300% or 500% of snowpack. not all snowpack is created equal. And I think that was a really important point to understand how
That
much
was-
of that. Yeah.
Yeah, that was a light bulb moment for me.
Isn't it
Sorry.
amazing? You know, that I've got to give a shout out. That is coming from one of our researchers here in the Montana Climate Office who has taken a product from NOAA called SnowDAS, which is really a useful product. It's a gridded product showing the amount of snowpack across the country. But what he's done is he's done that elevational thing and looked at not only where the snow is, but how it relates to normal where it is. And to aggregate that at a basin level and see that the snow isn't necessarily where you want it to be.
Right.
Is really useful. Or sometimes that snow isn't a good spot. I mean, if you're doing dryland ag in the high plains right now, up in North Dakota and Minnesota, that's a lot of good snowpack. That's going to recharge your soil moisture. If the timing's right with the melting, your soil moisture is going to be looking good in about a month. Really good.
And just for us, like when you go into a Wahi Dam, it's that lower snow that's going to flow to us that, is really going to help. And
really
then
help, but it doesn't help fill the Fort Peck Reservoir, right?
No, not at all.
Right.
So that
Or
is
like
important.
Yellowtail or like some of those huge ones that I knew this before this week, but you pointing out that Montana's just the hedgewater of all things just really hit home this week. I was like, wow, yeah. I mean, I knew it, but it's so easy to forget how important those mountains are.
Mm-hmm.
And I think another point that's really important is don't be deceived of one good year. The climate patterns, what you're seeing now is exactly what we anticipated in the climate patterns, which is this notion of going from extreme to extreme. Extremely dry years, extremely wet years. And even with all the projections of the snowpack right now in the California, Nevada region, they are not anticipated. We can go right back into drought by the end of summer. So it depends on what the temperature profiles are and what happens. So as you said, this may be good news for some producers and not so great news for other producers in our region. And that's why we'd like to hear from everybody as to what's happening in their backyard right now.
Yeah, absolutely. I mean, that if there's one story that I hope everybody here takes from this week is that it really, those local conditions matter. The way that the snow is melting matters. The way your soils are recharging matters. And that's those type of data are some of the hardest data for us to get at a national level. It really gets to the local conditions and its influence on farmers' fortunes, on producers' fortunes. So please keep an eye, as you all do, keep an eye on the soil, but also let us know, because that will really help inform everyone across all of these basins as to how conditions are evolving across the nation.
And I know we're going really long, so we will wrap this up. But one factor that I feel is going to be huge is wind. Do we have any projections if this wind is going to let up, or that's not something we know of?
I don't know yet. I don't have anything for you there yet. As you know, across the Southwest, especially, we're just about to get into the windy season. And if everybody remembers last year, when we not only did we have those extreme winds, but then we had fires kick up, and we had some really, really devastating fires that in New Mexico were just extremely accelerated due to those extreme 60-mile-an-hour winds. You couldn't fight the fires, right? I mean, boy, we could ask somebody from NOAA and see if maybe somebody's got a grip on the likelihood of that, but I don't, and I don't.
So Kyle, may you
predict.
Kyle, maybe you can give us some rundown on what happens with the winds as we go into our fire presentations for
Mm.
our June
Oh,
meeting.
that would be good. Yeah.